Okay, we're gonna start looking at the dynamics assignment. I've just returned to you guys, but I think there are quite a lot of issues in the answers. So just need to let you know what are some of the common mistakes. Right, let's look at the first one here, right? Okay, we have a toy car with a rocket engine that's moving along horizontal track as shown. So the car engine produces a constant forward force of 4.6 newtons. Right, let me adjust my keyboard a little bit. Make more space for myself. Right, so your car will lose mass as the exhaust gases are produced by rocket. Okay, then you have this VT graph here. So this is the velocity time graph. So take note. So this is your VT graph. And then tell you that at time t equals to 2 seconds, right? The mass of the car is 440 grams. Alright. So for the time t equals to 2 seconds, use the graph to determine the acceleration of the car. Okay, so for this, right, a lot of you use the straight line in distance. So what I did was that you just basically you did this. You extend up to 2 seconds this way, and then you found the gradient of this line. Okay, you're not supposed to do this because remember this is a VT graph. To find the acceleration at a particular timing, right? You need to use your tangent. Okay, so I don't think you can draw a nice tangent. Let me try to draw. So if I were to draw a tangent nicely, so it looks something like this, right? Something like that over there. Okay, so you have to take this tangent, then go and work out what is the gradient of this tangent. So if you do it this way, then you get your acceleration to be this value here. Okay, so roughly about this range. So I think I took about I think about 10% plus minus. Alright. Okay, so yeah, note that you should not be doing it this way. Alright. Okay, so this is question 1A, part 1. Okay, next let's look at the next one. Okay, you're supposed to use the answer in part 1 to determine the magnitude of the resistive force acting on the car. Alright, most of you could do this step. So you just basically what you're doing is that you took the car. Let me just draw a car above. Okay, so let's just say you do it like that. Alright, so this is your car. And then you know that your acceleration, whichever value worked it out to be, this is A equals to 2.73 meters per second square. Okay, and from there you could work out your acceleration. You could work out net force. So basically what I did was I found F net is equals to MA. Okay, so then you do this step here, right? But actually what I need to do is to draw the free body diagram for this one, because there are actually two forces involved here. Okay, there is a driving force, so that's called the engine force, Fe, and then there is the resistive force, Fr. Or in this case, okay, let's just use the notation given to us inside there. So let me just let me just use the notation. Okay, so their notation is this. What am I doing, man? Okay, so the notation is this. You're gonna have your F forward, Fw, and then you're gonna have your frictional force. Okay, so therefore, right, once you have this, right, then you can say, oh, your F forward minus away your frictional force is equals to your F net. Okay, you're supposed to find out what is F. Okay, so that will be F forward minus your F net. Okay, and this is equals to 4.6. Okay, so this is given here. Alright, yeah, so a lot of you just stop at this step here where you just found F net equals to MA and you stop there. Alright, it's not that's not what you want. You're supposed to find the resistive force. Alright, okay, next, explain how it can be deduced that the resistive force is increasing with speed. Alright, so the problem with this one is that a lot of you went on to talk about Newton's second law. You go and basically you say that because some of you went on to say because your frictional force is proportional to your V, therefore then speed increase, then therefore the frictional force increase, therefore acceleration decrease. Okay, this is not what we want. Okay, because the key word here is that you are supposed to deduce. Check this out. Okay, so you're supposed to deduce that the resistive force. Okay, so again here, right, I need you to use evidence from from the graph here, right? So if you look at this graph, go back to the previous page here, right? This graph, right, you can see that the gradient is becoming less and less steep. Okay, as you go on, it becomes less and less steep. Okay, so remember, because your acceleration is equals to delta v over delta t, if, sorry, hold on, mic drop, literal mic drop moment. So if your gradient is becoming less steep, right, this is becoming smaller as well. Alright, so if you go back to your answer here, okay, so this is the first mark. So we can see that when your speed is increasing, alright, the gradient of a VT graph decreases, therefore acceleration is also decreasing. So this is, okay, if I write out in words, right, this would be basically saying that, oh, as V increase, my dV dt is dropping, therefore my acceleration is also dropping. Okay, alright, then the next portion here is how you link it back to your resistive force increase. Okay, because we know this equation here, alright, if my, okay, this is my net force. Okay, maybe let's rewrite it in terms of, okay, if you look at this right now, right, if my A is decreasing, right, I can go one more step and say, oh, A decreasing, that means my net force is also decreasing. Okay, so if this is decreasing and this is constant, okay, that means your frictional force has to be increasing. Alright, so this is how you draw the link. Okay, there's no need. The question is not asking whether you can explain why your frictional force is increasing together with the speed. It's asking you how you show that your frictional force is increasing with your speed. Right, so just be careful with the phrasing of the question. Okay, next, you are given, now the toy car is rotated and is pointing upwards. It's suggested that the rocket engine produces sufficient force, okay, to propel the car vertically. So this is a suggestion. Okay, by considering the acceleration of the car at t equals 0 seconds, let me highlight this in a color because this is the important point. Okay, by considering the acceleration of the car at t equals 0 in the graph, comment on this suggestion. So now, you see the first step, right? Basically, right, you need to work out what is the acceleration of the car at 0 seconds. So that means you have to go back to your graph, to the graph again here. Okay, again, draw the tangent now. So now the tangent is something like this. Maybe something like this. Right, like that. Okay, then work out the gradient again. Then you get the acceleration value. Alright, so once I've gotten that, okay, so this is the value, right? So since the car is initially at rest, there's no resistive force acting on the car, and the forward force is just ma. Alright, so I think for this, right, it's easier if you can draw a diagram. Why is this hanging on me? Hold on. Okay, let's see. Okay, can. Okay, so I think it's important that you draw a simple diagram there. Let me just maximize this area. Okay, so I will draw my car now pointing upwards. Okay, the engine force is pushing upwards like this. Okay, let's just go right here. So this is F forward. Okay, and this forward here is equals to your 6.4 multiplied by the mass of the car. Okay, whichever mass it is, you don't know. Okay, and then you're going to have your weight, and weight is equals to 9.81 times m. Alright, okay, so but if you look at this, right, so now you have this forward force here, you have no resistive force. Hold on, let me go back highlighter. Okay, you have at rest, therefore no resistive force. Okay, and then forward force is just equals to 6.4 m. Okay, then your weight is more than your forward force. Alright, okay, so essentially the engine does not produce enough force to propel the car upwards. Okay, take note of the comments here. Okay, the argument should be based on weight and thrust, okay, rather than on the center of the compression acceleration. Okay, as if the car were accelerating simultaneously in the opposite direction. Okay, what this means is that you cannot say, oh, because upward acceleration A is equals to 6.64, downward acceleration is equals to 9.81. Okay, then therefore Since G is larger than A, therefore won't work. You cannot compare as acceleration this way lah. Okay, the correct way of doing it is to work out the net forces. So you need to convert everything to forces. Alright, so that means you have to do like what I did above. Okay, convert this to a force. Let me just change color. So this one, so this is your F forward, right? And then this is your 6.64 times M, and then weight is equals to 9.81 times M, 9.81 times M. Okay, then your net force F net is equals to 9.81 minus 6.64 M, which is downwards. Okay, so your car won't accelerate upwards. Okay, so compare the force, work out the net force, then go and find the direction of your acceleration. Okay, don't compare acceleration directly. Right. Okay, next question 2. You have a constant resultant force acting on an object A. Variation with t of the velocity v for the object A is shown in the graph below. So again, you have mark out some of the terms that are important to you first. Okay, so you're going to have a constant resultant force acting on object A. You're given the vt graph again, so this is v and this is t. All right, and realize that this is a constant gradient, right? Okay, mass of the car is 840 grams. Calculate for change in momentum. Okay, this one was generally okay. Most of you can do this. It's just basically applying this formula directly Okay, but some of you got careless and then you go and divide by time. Okay, if you divide by time, right, you'll actually be doing this. You're doing delta P over delta T, which is actually equals to your force, which is just the next part, which is just this part here. Okay, but I gave you ECF for this one. So this is delta P over delta T. Okay, some of you for part 2, right, you went to find acceleration first. So what you did was this. You took note of the original speed. So you did let's use black, so you did A equals to V minus U over T. That will be 8.8 minus 4.2 divided by 4.0. That will give me 4.604, which is some value lah. Then after you go and do F equals to MA. Okay, not wrong lah, but then basically these two parts are linked, so you should make use of this relationship to solve, and not this. Okay, but you get the same answer. Okay. Okay, next. Okay, two objects. Okay, force is removed at 4.0 seconds, so object A remains at constant velocity. This constant velocity is at 8.8 meters per second. Right, let me double check. 4 seconds. Yeah, 8.8 lah. Okay. Okay, so let's just write it here. This UA is equals to 8.8 meters per second. Okay, then after they collide with B, after that they will stick together. So after collision, let's just draw at the bottom here lah. Okay, after collision, right, this will become A plus B with a velocity of V equals to 4.7 meters per second. Okay, so calculate change in momentum. Okay, so for this one here, part 1, right, some of you got confused. You go and you try to use conservation of momentum to solve. You are doing similar things, but then you are not answering the question lah. What the question is asking you to do is calculate the change in momentum for A, then calculate change in momentum for B, then compare together. Alright, so for A, right, you will have MAVA minus UA. So over here, MAVA minus MA times VA minus UA. Sum in the values. This one you should get a negative value. Keep the negative sign because this is not asking for magnitude. It's asking you for the change in momentum. Okay, so this one over here, let me underline this. This change in momentum. Okay, this is asking. Okay, this one that means it's different from magnitude. Okay, so keep the negative sign. Right? Keep this negative sign. Hold on. Yeah, keep this negative sign. Very important. Alright, then next for B. I think it's straightforward. Then therefore it's actually the same. Okay, so show that the magnitude then because of these two values are close enough, right, you can therefore say, oh, magnitude of change of momentum of A and that of B is the same. Okay, change is opposite because of your minus sign. Your minus sign here. Okay, so this is what I'm supposed to show, like equal and opposite direction. Alright. So yes, explain how your answers obtained in part 1 support Newton's third law. Okay, two main points here. Okay, first, right, we need to show change in momentum. Okay, so change in momentum is equal in magnitude. Alright, so this one is fine. So what we already know is, okay, let's just write the top here. So what we already know is this. We know that delta PA is equals to negative delta PB. So this tells you that this is opposite direction. Okay, so that's fine. Then we know that delta PA, the magnitude of delta PA is equal to the magnitude of delta PB. This shows you equal magnitude. Okay. The last thing you need to show is the forces are the same. So it's a bit like a bit as expected lah. But then if you think about it, right, if you do not say clearly that your force, your change in momentum takes place over the same time, right, you can't make any conclusions. So what I mean is this. So for example, you have to find FA, right? FA is force on A due to B. This is basically saying, okay, delta PA divided by delta T. Okay, then you want to find force on B due to A. This is delta PB over delta T. So without saying that, let's call the time A and B. Okay, without saying that delta TA is equals to delta TB, you cannot conclude that FAB has the same magnitude as FBA. Okay, so if we go back to this equation here, we know that delta P and delta PB have the same value. Okay, same value, but just opposite sign. But for the two forces to be equal, right, this timing has to be the same. So this one has to be clearly stated here. Alright, so if you look at the mark scheme, okay, you have time of collision is both the same. Alright, so therefore the forces are equal. Okay, since they are opposite direction, the forces are therefore opposite as well. Alright. Okay, last part here. By reference to the speeds of A and B, explain whether the collision is elastic or not. Remember, elastic collision is a conservation of momentum and conservation of KE. All collisions, right, your momentum is conserved as long as it's a closed system. Alright, so here, right, you can of course go and show that KE is conserved. KE is not conserved. You go and find KEA before, KEB before, then find after as well. But that is actually too much work for one mark. So here what this is asking you for, right, you can just basically make use of, okay, if it's a conservation, remember we talked about let me write down. So for elastic, right, I can do two things. I can do conservation of momentum plus conservation of KE. Okay, in elastic, I can only do conservation of momentum. Anyway, this conservation of momentum and conservation of KE combined, right, I can get this U1 minus U2 equals to V2 minus V1. So all I need to do, right, is to use this formula to check. Okay, so let's try to sub. Okay, let's write it out again. So let's say this is, oops, sorry. Where's my app? Okay, so if I were to write this, okay, let's let one be A. So this will be okay, let's write UA minus UB equals to VB minus VA. Okay, UA is 8.4, UB is 0. VB and VA is at how much? 4.7. Okay, but I can see it's not correct here. 4.7 minus 4.7. Okay, so this is not equal at all. Okay, so if I want to prove this properly, right, I keep on telling you that I shouldn't prove it this way, but let's try it. Let's just write it properly. Okay, so this one will be 8.4 minus 0 VB minus VA will be equals to 4.7 minus 4.7. Okay, so this is 0 and this is 8.4. Okay, so since these two are not the same, right? Therefore, this is an elastic collision. Alright. Okay, that's it. Yeah, but I think it's time that you guys, some of you come for consultations, because you know it's very hard to try to help you to do well lah. So I already told some of you that you should come down. So please come lah. Just let me know. Just text me. We can always find a timing. Okay. I because next 2 weeks I'm essentially quite free at home. So you just let me know lor. See which day you want to do. Okay. You can come in pairs. You can come on your own. You will be down on Zoom anyway. Alright. Okay. That's all I have for you guys. Thank you. Bye bye.